Okay, so the second part is that since we have all the pi's, pi 1 and pi 2, so we will say that the pi 1 is same for the model and prototype, as well as pi 2 is same for model and then prototype. Okay, so let's do that. So we will say pi 1 for model is same as pi 1 for prototype. This is a necessary condition for similarity. So in that case, for power of the model is 280 watts, and then the rotational speed is 1200 RPMs. I can convert it into radians per second, but since this value is on the both sides, so there is no need to convert it. Okay, so I will just put as it is. So 1200 RPM to the power of 3, and then we have the diameter, which is 90 centimeters, 0.9 meters, times the density. I will just put as density because it is same for model and prototype. This one is power of 5. Okay, then comes the prototype. So we have the power of prototype, which is unknown. We have the omega of the prototype, which is unknown. And then we have the diameter of the prototype, which is 50 meters. And then density. Okay. So, and then we said that densities are equal. We have two unknowns, the rotational speed and then power. So what we will need is that we will need one more equation. So that equation will come from the pi 2. So I will say that pi 2 of the model is same as pi 2 of the prototype. In that case, I will have the velocity of the model, which is 12, the rotational speed of the model. So again, I can convert it, but since it is on both sides, it will not do anything. So that's the reason that I will just put it as it is. And the diameter is 0.9. The velocity of the prototype is 8. The angular velocity of the prototype is just, I will put it as it is. Diameter of the prototype is 50. Okay, so you can see that we can find the omega from here because it is the only unknown, and then we can substitute it back to here to find the power of the prototype. Okay, so let's do that, and let's calculate first the omega and then replace it back here. So omega of the prototype will be that 8 times 1200 times 0.9 by 50 times 12. Okay. So if I do that, so this one is 14.4 then RPM. Okay, so you have to be careful because we used RPM here, so it should be the RPM. That means in 1 minute, this amount of a revolution is there. So again, put the same value back here. So we will have 14.4 RPM, and then we will need to find the power. So it will be just this one multiplied with that one. Okay, so let's do that. So then power of the prototype becomes 256,059 watts, or you can say 256 kilowatts. That's all. So it shows the importance of the similarity analysis. If we have the model, we can get the prototype values by using the model values. Okay, that's all. So if I summarize, we firstly generated the non-dimensional numbers, which we had 2 of them, and then we said that this one should be same for model and prototype, this one should be same for model and prototype for the similarity, and then we have calculated first the rotational speed, which is 14.4, and then the power, which is 256 kilowatts.